Hey, so I wanted to jump in here real quick and say that there's not really a good, clean, easy way to do this in Excel. So I'm cheating a little bit and I'm using the program that I am the most comfortable with, the one that I do my statistical research in. So you're going to kind of get a peek behind the scenes at how statistics research can look, how statistics coding can look, right? So don't be alarmed. Don't feel like you have to learn how to do this. This is an example. This is me demonstrating the ideas behind these concepts. So no panicking if you have no idea what's going on, okay? So we just talked about in the module, this little example of students and prices of their textbooks, right? So we have the prices. This here is the prices that you saw. This is our whole population, right? Our population of interest in this case is the students in this classroom, are the students in this classroom. So we've got all of their prices and we know the population mean because we have the data for the entire population. What is that called? That's called a census, right? We have the data for the entire population. That's the population mean here, right? That is our population mean mu. Suppose we don't know this information. Suppose we wanted to sample. So only 5 students are willing to tell us what they paid, right? Only 5 students are willing to tell us. 5 students that are willing to tell us what they paid these 5 amounts, right? These 5 people are our sample from this population, right? And we've got the ability to then look in and say, okay, well, our sample mean is this value, right? The mean of these 5 values. I'm going to go ahead and cheat and tell you, hey, look, you just got to compute it this way. It's 368.4, right? That is our sample mean. Is it close? Yeah, kind of. It's 8 away, 8 on a scale of 360. It's not even a percent, right? We expect it to be kind of close, right? We're sampling from this population. We're taking 5 from 20. We expect it to be close. Let's do it 4 more times. Now we have 5 different samples of size 5, right? So we're sampling 4 more times. We're taking the mean 4 more times, and we've got our sample means, right? I forgot to display them. I'll go fix that in a minute. But the values, I will tell you now, and then I will pause and go fix it, are close, and one of them is very far away. All right, I fixed my code, added a line, and now we can see the display of these 5 sample means, right? 368, the one from before, 352, 392, 378, 366. Kind of, I would call that scattered around the true value, right? Remember that our true value is 360. Some of them are close, some of them are far. What's happening here, right? We expect, that's what I'm getting to here, right? We expect that our sample mean is going to be close to our population mean, but we're not guaranteed that it's going to be exactly the same, right? We expect there to be some variance. And because we expect there to be some variance, we can then figure out, okay, well, actually, there's going to be a distribution of where that is, right? The location of all of these different possible sample means. So what I did is I went in and I silenced my phone, and I went ahead and we did it 94 more times. Now we have 100 samples, all of size 5, right? We've sampled from this 20-person population 100 times, and each of them we pick 5 of those numbers, right? So we get this big long list of 100 sample means. And we have a tool to look at the distribution of a group of numbers, right? What does this data look like? This is data, just like we worked from before. Just because we sampled it, just because there's sample means, it doesn't make it not data, right? It's sample means from our data. And we've just done it 100 times. And hey, look, it is centered on the population mean, but it's kind of got this curve to it, right? It's more often than not close, but it can vary all the way from what? It's probably 315 to 405. That varies a lot. So we can see there is sampling variability in the sample mean, right? This distribution is an approximation to the distribution of the values of the sample mean that would have been observed if we had considered every possible sample, right? If we had considered every single possible combination of 5, that would be the full possible distribution of our sample means, right? So just like, in this case, that would have been possible, computationally feasible. In the world, right? If we're interested in data from all Americans, we can't sample every possible sample. That's absolutely feasibly impossible, right? So what we can do is figure out a way to find the distribution of what these sample means are going to look like, right? And you know how to do stuff with these. If we find the distribution that it is, which we will, you'll be able to say, okay, well, the probability of getting a sample mean, this big is 5%. The probability of getting a sample mean, 350 or lower is probably about a third. We can now start to make probabilistic statements about our sample mean, which is going to be the tool we use for the next huge chunk of this class. So hopefully you're paying attention and this is all sinking in. All right, let's move on.